kind of race through. This is a continuation of 2.3. I kind of raced through the question 5. But just to summarize, we're looking at the product rule, which says that when we're trying to find the derivative of two polynomials multiplying each other, these are just examples, of course, plus 7x, let's say. The product rule says that you have to take the first, take the derivative of the first one and multiply it by the actual function of the second one. Not the derivative, the actual function. And then add that to the actual function of the first one and times the derivative of the second one. So if you were to label these, you would just call this one f of x and this one called g of x. And a smart thing to do is then find your g of your derivative of this function, and that's using the power rule. So this becomes 2x and this becomes plus 7. So right away we have the derivative of that function right there. And then it'd be smart to find the derivative of this function and simply call it f prime, and the derivative of this function using the power rule, 2 times 3, 6x plus 6. And if you don't know the power rule, you have to always build up on your building blocks. You have to be comfortable doing the derivatives pretty fast. But now that you have a definition of each thing, you can just always just take the product rule and replace each term with what you found. So we're looking for that. So what was g of x? It's right up here. Plus, so these have to multiply. So you put brackets around them because they have to distribute properly. Or you can just leave them like that. Plus f of x. So we're talking about plus. F of x is right here. Times the derivative of g of x, which is this. And now that you've done it like that, you do not have to expand and solve this if you don't want. This is done. You can plug x in, and whatever total you get, just remember that you have to multiply these brackets, whatever the content is after x, and then add them. You must multiply first, and then add. And whatever the total is, that's the derivative at this function, wherever x is. And just, it's never going to be written out as functions. It's going to be written out as I wrote it, two polynomials. But you can replace it with these things and just sub it in. And this right here, because some people said they got confused when I called it the chain rule. Your book calls it the power of a function rule for integers. And what they're talking about is when you have a polynomial like this inside an exponent, you can't just take the derivative and then put it to the power of 3. You must follow this rule. And right here you can see that right there what I was saying. The power rule is a special case of the chain rule. That's why I call it the chain rule. And the chain, what it says, and this is what they write right here, very confusing, but you'll see that this is no different than the product rule because it's this bracket times itself 3 times. And if you do it the long way with the product rule, you'll end up with this. 3 to the power of not 3, but 2 times the derivative of what's in this bracket. And what is the derivative of what's in that bracket, by the way? It's 6x plus 7. So you actually just have this. So you would solve for x, you'd square it, you'd multiply it by 3, and then you'd multiply it by whatever you solve in here. Now, obviously, expanding these to have a derivative equation would be a pain, right? So if you are looking for when x is 2, why not just sub it in here? So 2 squared is 4, times 3 is 12, 2 times 7 is 14, 12 plus 14, 26. Then sub it in here. 2 times 6 is 12, plus 7 is 19. Now you have just numbers to work with. A lot easier than expanding and solving a derivative equation. So now you just take your calculator, you square 26, multiply by 3, then multiply it by 19. You can square it by 2, multiply it by 19, and multiply by 3. That's fine, but whatever you do, you must square this number before you start multiplying. And that's because all of math follows the rule of order of operations, which is BEDMAS. Now, I sort of skipped through one of them, and one thing I'm going to do for this one is I'm going to keep a copy of the product rule in front of me as much as I can, because you'll see that if you just keep it in front of you, that's the power of functions rule. If you just keep it in front of you, and the book has good examples after each one to explain how they derived the product rule, and a few examples of how to do it. And a lot of students don't even read their textbook, which is a shame. Sometimes the textbook's more clear than the teacher. All right. One thing I notice about every human being on the planet is we all like shortcuts, and unfortunately, we never learn the long road, and the long road, if it's the hardest road, is usually the right road. So we're up to number 5, and I noticed that I kind of just glossed over it, and then I realized that's not quite fair. Now, I'm not going to do them all like I did, and I think I did the first one. Okay, but I'm going to show you how to do each one in terms of this. So what's this, remember? And I'm just going to keep this part up. So that's just the product rule. I'm going to get rid of the other stuff. And we're looking specifically for this x value of x is equal to 2. Let's make that a bit bigger. So if I start with this, the smartest thing you can do is say, I'm going to call this first one f of x, and I'm going to call this second one g of x. And then I'm going to figure out my g of prime, g prime of x, and I'm going to figure out my f prime of x. All right, so I could just leave these nicely like that. What's my g prime of x? Well, it's the derivative of whatever's in here. Well, only the x matters, and the derivative of that is 1. So really, g prime of x is not going to matter that much. What is f prime of x? Well, 2 doesn't matter. It's just 7. Now that I have each thing figured out, I can take a lovely copy of my product rule and replace each thing, okay, with that. Bring down my plus. Don't forget your plus. And each thing like that. How easy is that? Just make sure. See, now this is 1. There's no need to even include it. Boom. I now have a derivative equation, and I can just plug 2 right in. 2 minus 3 is minus 1. Minus 1 times 7, minus 7. 2 times 7, 14. Plus 2, 16. Minus 7 plus 16, 9 plus 9. Therefore, that is the slope of the tangent when x is equal to 2 for that, for y, for this function. That's a total function. By the way, what kind of function is this? How can you always ever spot functions? Well, you might say, oh, it's just a line, but no, the biggest power in here is going to be when these two multiply. It's going to be 7x squared. That's going to be the biggest power. That's a parabola. Helps to learn to spot them. Let's do the same thing, but for b. Same thing for b. So always start with what they tell you. You're looking for this number, and like I said, I'm not going to do it. I'm just going to show you how to do it. And we're going to call this f of x, and we're going to call this g of x, and we're going to figure out, yeah, I don't know if I have to do this f of x and g of x over and over again. Why don't I just do it like that and put a little prime over it? Prime, prime. So what's the derivative of this? You just got to focus on that. It's minus 2. What's the derivative of this? 2. Look how easy that is. Now you just take your product rule again, you put it down, and replace it with everything you know. Yeah, so I'll go in the right order. Minus 2 times g of x plus f of x times the derivative of g of x. And now in Mathese, we like to have our numbers up front just so that we can spot all our numbers. It's a lot easier that way. Now you could expand it, and if you're told to expand it, you can. But in this case, we're looking for specific x. What's 2 times a half? It's just 1. What's 1 plus 1? 2. What's 2 times minus 2? Minus 4. Over here, what's minus 2 times a half? It's minus 1. What's 1 minus 1? 0 times 2, 0. So we can see that we ended up with minus 4. So that is the slope of the tangent when x is equal to minus 1 for that function there. What kind of function is this? There's the biggest x times the biggest x squared. This is a parabola. Helps to know what you're dealing with. Over and over and over again. So you can see how easy it is. If you have this is what I call the master note. Keep an example, and then you can just pull out your master note and follow it over and over again. That's why I encourage you to keep master notes. And, you know, I get that nobody listens to me, and that's fine. So, you might say, we've got a big long polynomial. Same rule. This time we're looking for x of minus 2. You know what? If I'd been really smart, I would have just left those there too. So we're going to call this one f of x, and we're going to call this one g of x, and I'm just going to figure out the derivative. So you might be confused and say, oh, I want them in the power order. I want this first and that next and that next. You can do that, but the derivative is still going to be the same. So what's the derivative of minus 2x? It's minus 2. What's the derivative of this? 2 times the minus 1 that's here. It's minus 2x. Put it in brackets. Boom. I have my derivative of fx. I should make it a little smaller. My writing's a little crazy. What about the next one? Well, that's in power order. What's the derivative of this one? 2x. What's the derivative of that? Plus 1. And the do it like that. And the 2 minus 2 doesn't matter. Derivative of a number 0. Boom, I have it. I'm set. I'm ready to go. So I take my product formula, I put it down here, and wherever I see the term I'm looking for, times g of x. Oh, boop, 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 boop. Come on, come on, come on, come on. Plus f of x. So see how easy it is now? Times this. Now clearly expanding and simplifying this is a nightmare. Why bother? We're looking for minus 2. What is minus 2 times minus 2 plus 4? So what is minus 2 plus 4 here? It's 2. So you can replace that entire thing with plus 2. What is minus 2 squared? 4. Plus minus 2? It's the same as minus 2, so now we're down to 2. And minus 2, 0. Well, that makes this easier. That just disappears. Because 0 times whatever this is 0. Minus 2 here. Minus 2 squared is 4, so we get minus 4. This minus is independent of the x. So I get 3 minus, what's minus 2 times minus 2? It's 4, plus 4. So I get 3 plus 4. When this minus 2 squared, it's 4, but I get minus 4. Easy to see that those just cancel out, and I'm left with plus 3. Minus 2 times 2 here, minus 4, plus 1, minus 3. What is minus 3 times positive 3? Minus 9. Plus 0, minus 9. So this is the slope of the tangent when x is equal to minus 2 for that equation. A lot easy, very easy when we follow the same thing. It's sort of why I'm doing it like this. Get rid of all those. I think I just did that one. Okay, and you might say, for this one. Nah. It's the same thing. Where's my f of x? Right there. Where's my g of x? Right there. And you might say, we've got powers, chain rules. That's okay. What's the derivative of this? That one's easy. It's 3x squared. What's the derivative of this? This we have to use the chain rule. 2 comes in front. We get 3x plus 7. We reduce the power by 1. And we multiply it by the derivative of the content of what is in here. What's the derivative of the content? It's only that. Power of 1 comes down. 3 times x to the 0 is 3 times 1. It's 3. Now, when we're at this stage, to make my life easier, let me get rid of all my messiness. And I don't need to the power of 1 there. You're allowed, see how it's this times this, whatever's in this bracket times this? You're allowed to instead multiply the 3 times the 2. 6. Just keep the number 6 out. Boom. That's the derivative of that. If you don't believe me, you do work it out as a product, this bracket times this bracket, and do this, and you'll get this. Okay, so but now we can just put it up here as, and I'll make it a bit smaller, the derivative of g of x. Now, I take my product rule, and I just put the things I found down. Look how nice and easy this is. I wish I hadn't put that in circle, but whatever. Now, put that. What was f of x? This one here, times. Don't forget the 6. That. Any numbers can just go up front if you want to make your life easier. Because when you're multiplying things, 5 times 2 times 3 is the same as 3 times 2 times 5 is the same as 2 times 3 times 5. You're allowed to rearrange things that are doing the same thing to each other any way you want. The same as 5 divided by 6 times 2 is the same as 5 times 2 divided by 6. Don't believe me, try it out. Same with numbers. Addition, subtraction rather. 5 minus 2, so I'll put a plus 5 here. Minus 2 plus 6. If they're all adding or subtracting, I can rearrange it any way I want. And these results will all be the same. It'll all be 9. And that's called the commutative property. It's where you get to rearrange anything as long as the function fits within the order of operations. So as long as they're being multiplied or divided, you can rearrange them. As long as they're being added or subtracted, you can rearrange them. Now, here we have a function. This is a derivative equation. It's the derivation of derivative of y. We can just take our minus 2 and plug it in. 3 times minus 2 minus 6 plus 7 minus 1 squared plus 1. Minus 2 squared 4 times 3, 12. 12 plus 1, or sorry, 12 times 1, 12. Over here, x cubed is minus 8 because a negative cube stays a negative. 6 times 8 minus 2 times this is minus 6 plus 7 is 1. So really, we only care about minus 6 times, or plus 6 times minus 8, minus 48. And then we add them. So what's 12 plus minus 48? It's the same as minus 48 plus 12. Doesn't matter how I do it. You can also do this. This is a bit of a... I won't do that because I don't want you to get confused. It's minus 36. But what I was going to say is you can temporarily factor out minus 1 and turn that into minus 48 minus 12, which is easier for students to see that it's 36, and then you can multiply it by the minus 1 again. That's because some kids have trouble with negative numbers. Whoop. Yeah, I can get rid of that. Get rid of that. You can see if you keep this format going, it's the same thing, and I think I did that one for you last time. Just got to do the chain rule when you do the derivative of it. And this one you might say, it's 3 functions. It's 3 functions. But in this case, for 3 functions, and I'm just going to write the 3 functions, they discovered that it's the function f times the function g times the prime of x. Then it's the function g times the function h times the prime of g. And then it's the function g times the function 8 times the prime of the function. So all that means is that I need one extra h of x and h prime of x here to figure it out. So what I'll do is I'll assign this one to f of x, this one the g of x. Well, that's f prime of x. And this one x to h of x. What's the derivative of h of x? It's 1. So I figured out the derivative of that. What's the derivative of f of x over here? It's 5. What's the derivative of this one? It's also 5. And then I just take my rule, which, by the way, if you're not familiar with it, it's in the book. We covered it. And I can replace each thing beautifully. And what's the derivative of h of x? It's 1. Well, there's no need to put it in there. And then just don't forget that you're adding them. So I need to find the function f now, times the function h, times the derivative of g. Derivative of g is there. Now, I like putting my numbers up front. That's just me. I also like putting my x's up front. Okay, and then the last one, you grab your function g, times your function h, times the derivative of your f, which you discovered was 5. So I'm going to do the same thing with this. 5x, I'm going to put in front of it. And now you don't have to solve. You're looking for when x is 3. So when x is 3 here, you get 15 plus 2. Times when f is 3 here, you get 15 minus 2, 13. Plus 5 times x, 3. 5 times x, 15 plus 2, 17. Plus 5 times x, what was x? 3. And what's 5 times x? 15 minus 2, 13. Notice a lot of the numbers are similar in different spots. You can get your calculator to do this. A good way to do something fast like this is the same as 10 times 17 plus 3 times 17. 3 times 17 is 51. 10 times 7 is 170, so it's 221. Might be wrong, but whatever. So here's the same thing. 3 times 5 is 15 times 17. That's the same as 10 times 17 plus 5 times 17. 5 times 17 is the same as half of 10 times 7, 170. Same as this. And half of 170 is 85. So what's 170 plus 85? 255. So that's called trickery. Why would I multiply 9 times 1,117 when I can multiply it by 10? And then I know I'm going to have one less. Why would I subtract 117 when I can subtract 100? And then 10. And then 7. Okay. So 15 times this is the same as 130 plus half of 130, 195. Why would I add 195 to 255 when I can add 250 to 200? So that means when x is 3, the derivative, or the slope of the tangent of this function is 672. Okay. Determine the equation of the tangent to the curve. So I'm only going to go so far with that. It's the same thing. And boy, do I wish I just kept the product rule up. So we'll try to do like that. I'll try to crop it, and I'll try to do one at a time. And who cares? I can just do my own product rule. It's just f times g prime plus g times f prime. Okay, here's what I recommend you do. Now they want the equation of the tangent. What is the equation of the tangent? An equation of the tangent is always in line format, because a tangent rather, is always a line that is touching the curve in one spot at 90 degrees. That wasn't one spot, but you get the idea right now. I didn't quite get it. Right there, at 90 degrees angle to that one dot. And so as you can see, a line will always be in that equation. So we need to find the slope first. To find the slope, we need to find the tangent. So we have this, and I'm going to assign this is my f of x, this is my g of x. Just move it all down. Okay, so I'm going to assign this is my f of x, this is my g of x, and I'm going to solve f prime. Well, that's 3x squared minus 5. So that means my prime is 3x squared minus 5. You can just use the power rule. If you're not comfortable with this, you need to go practice your power rule. What's the derivative of that? 6x minus 2. Power rule. Power rule. Bring the power down, multiply it in front, lower the power by 1, multiply the coefficient by the exponent you brought down. Now that I have g of prime and f of prime, I can just substitute in nicely, like that. And you do not have to expand, you do not have to solve. Just remember it's a big old plus here. And then I have to take my g, and now my f of x. Now I have, and always remember to put brackets, now I have a formula for the derivative at this point. This point is only going to be relevant when I figure this out. X here is the point that you're always finding the tangent for. So if I put 1 in here, I get 1 minus 5 plus 2. So that's 3 minus 5 minus 2. Put in brackets just so you remember. Here I get 6 minus 2, 4. So 2 minus 2 times 4 plus 3 minus 2, 1. No point really putting it. And 3 minus 5 minus 2. What's minus 2 times 1? Minus 2. What's plus minus 2? Minus 2. What's minus 2 times 4? Minus 8 minus 2 minus 10. Therefore, the slope that's going to belong in the tangent equation belongs there. How do I figure out the other things? Well, that's why they gave me the point. I can now put my 2 minus 2 here, and my 1, which is kind of pointless, there. And I get this. Minus 2 is equal to minus 10, the slope, times 1x plus b, and I'm solving for b. Notice anything that was subtracted over here becomes addition on the other side. Anything that was a multiplier over here becomes a division on this side. Anything that was a division over here becomes a multiplier over here. Anything that was added over here when I subtract it becomes a subtraction over here. So it becomes minus 2 plus 10, and I get plus 8. Therefore, the full equation for this line is y is equal minus 10x plus 8. This line will be the line that touches 1 comma minus 2 of this function at exactly 90 degrees to that point, a tangent line. 90 degrees? Yeah, 90 degrees. By 90 degrees, I mean if I drew a curve here, it would form a 90 degree angle with a line that I draw straight through the graph. Hard to explain. You should know what a tangent is by now. There's my explanation. Okay, so we'll go down to here. And number 7. Determine the points where the tangent is horizontal. What is the definition of, what is the slope of the line that's horizontal? Any horizontal line has a slope of 0. So that means the tangent of this, the tangent, is going to be equal to 0. Not the line, the tangent. So we have to find the tangent formula. Product rule. This plus, and why am I not making a derivative of that? Because that's not irrelevant. The number there just becomes nothing. Well, does it become nothing? No, I think, no, it doesn't. Sorry. The smartest thing to do here is first to expand that once. 58. Because as you can see, that 2 affects the tangent. You want to make your life a little easier, you can instead expand it over here. You'll come up to the same thing. So had I not done that, I would have to use the product rule 3 times, which is fine, because when the derivative of this one becomes 0, 1/3 of it's going to be 0. But this ends up being a multiplier in 2 other of the equations. So that's important to notice. Here, let me do it both ways. So that's as if I expanded it through. And let me show you the product rule for this one. It says that I have to take the function g, f times g, times the prime of h. And then I have to add it times f times h times the prime of g. And then I have to add it to g times h times the prime of f. If I assigned an f here, a g here, and an h here, and I follow that rule, here's what I get. Now, what's the prime of h? Just 1. So we can forget it. Plus, and I'm doing this part. So I almost made a mistake. Very easy to do. What's the prime of g? What's the prime of g up here? It's just 1. So we don't have to write it. And here's the last one. Don't forget, you gotta have a plus in between. So the last one, there's the g, there's the h, and here's the one that disappears. What's the prime of f? What's the prime of a number? The prime of the number is 0. 0 times that times that. But you'll see that had I just ignored that number and done the product rule with this, I would have missed out on the important 2 that multiplies both of them. Now you can include that 2 by putting it in there, because this will be the same result if I do this one. I'll show you this one. It'll be this times the derivative of that, which is 1, plus this times the derivative of this, which is 2. Oh, look. So if I expand this in, what do I get? I get that. Same thing. This was a little bit easier to do than making sure I didn't make a mistake there. So when you see a number here, I suggest you just expand it through either the first one or the second one, whichever's easier. If not, you'd have to follow a triple product rule so that you don't lose the 2 in front, or you can follow the product rule for these 2 so long as you remember to put a 2 multiplier in front of both of them. Tricky, right? Easy to lose touch. Anyway, we now have a derivative, okay? And to solve, this is now a derivative formula for y. To solve, we have to make it equal to 0. And some things you can do, and some things you can't. In this case, you do have to expand it. So what's 2 times x plus 2x plus 2? Like numbers, minus 48 plus 2, minus 56. 2x plus 2x, 4x. So here's what you're left with. So far, so good. let's see, half of that is 25, 28, 14. So that means at the point 14, this will have a tangent line that's horizontal, but I need to know the y value. So I need to pull back the original equation, which I can barely see through the thing. And I need to put in x in here, 14 minus 25 minus 15 times 2, and 14 plus 5 plus 15. Oh, you might be better at 5 squared than I am. I think it's 225. Yeah. And it's minus times 2, 450 minus, which means the point on this graph is 14 comma minus 450 when the tangent will be horizontal. Now that's a point they're trying to make. What kind of graph is that? An x times an x makes an x squared. Where's the only spot on a parabola where the slope is horizontal? Right at the vertex. So you've essentially found the vertex. Now the reason this is going to be useful later on, especially chapter 3, is if you're dealing with cubic curves or to the 5 curves, finding where the slopes are 0 will give you the local max and the local min of the curves, also known as turning points. So what calculus is letting us do is it's letting us analyze complex behaviors, complex models, and predict what they're going to do and where they're going to do it. This is important for all sorts of scientific modeling that's complex, including climate change, virus control, if only I could, cancer rates, cell degradation, anything with complex influences. And you can see, like, for instance, meteorology. 20 years ago, they couldn't tell you what the weather was going to be in 3 days. Now they can nail it up to 14 days in advance. Pretty incredible, actually. Stock markets, the economic model, business models are incredibly complex, and they use exactly this. And people who get good at it become rich. Not that this should be your motivating factor, but we all know a lot of things in life people think about as money. Use the extended product rule to differentiate the following functions. Do not simplify. So they're making our life a little bit easier. So when you're dealing with 3 products, the simple way to remember that I did before, and I guess I can do it long way, h prime of x plus, and we've already done it, right? G of x times h of x. Well, actually, I usually skip that one. So do f of x times h of x times g prime of x plus, God help me, there we go, f prime of x. There we go. So it's very clear, and I'm going to just I should keep all my product rules. I should keep a master sheet myself. It's very much easier if we assign stuff, right? And we'll skip this one for now. It's the same thing, though. And our h of x will be this one. Now, I'm going to go down below and do the prime of it. And if this prime has to use the power rule, I have to take this, put it in front, multiply the bracket, and lower that product by 1, which becomes 1. But I also have to multiply it by the derivative inside. What's the derivative inside? Fortunately, it's just something easy. It's 6x. What's 6 times 2? 12. I'm going to put the x up front too. So I'm left with 12x up front. Power rule for this as well. I must take the 4, bring it in front, and lower the 4 by 1, 3. And I must multiply it by the derivative inside. Well, this is the only thing that gets derived. The 3 is ignored. So that becomes minus 3x squared. So that would go right there, minus 3x squared. But what's minus 3 times 4? Minus 12. So I might as well put minus 12x squared right there. Make it a bit smaller so I don't interfere with the bracket. There we go. Now, and I'm going to put it a bit over here. So right there, we've got f prime, we've got g prime, and we've got h prime. And we just take our formula right up here, and we fill in the blanks. So we take f of x times g of x times the prime of h of x. Oops. Shouldn't put the little prime symbol so close. And then, and let's just give ourselves more breathing room here. And then we must add f of x. And you might think, I'm quitting calculus. That's easy when you do it this way. Times h of x. I'm just following the product rule up here. Times the g prime, which I figured out was this. Let's move it to the left even more. And now finally you have to add the g of x, much easier when you do it like this, times the h of x times the prime of f of x. Great. This here is a working formula to find the derivative of this. This is saying the derivative of y based on changes of x. Or if you want, the rate of change of y based on x. Obviously, you would not want to simplify that. I'm not going to do this one. It follows the exact same method I did up here. Just remember the chain rule, and if you don't know it, it's incredibly important to learn. Chain rule saves your life. And just remember that the chain rule is just an extension of the product rule. This would be the same product times itself 4 times. It's just simplified like this. So it's the derivative of the content times the exponent in front lowered by, as a multiplier, the exponent lowered by 1. All of it multiplied. I'm not, as I said, I'm not going to do every question, especially when it's the same thing. Use the extended product rule. We just did that. Now, they love word problems, right? Now, this one's tricky and kind of mean. Okay. Do that. And I might have to break this up, by the way. So we have always read, we got a 75-liter gas tank. So it's just a volume, right? That holds 75 liters. After a number of hours, called T, the remaining volume in liters is determined by this. So we can see that it's with this minus here. If we expand that, this is going to be, it's going to be an upside. Is it going to be upside? I don't think it's going to be an upside down parabola. It's a parabola though. And it's clearly going to be empty after 24, because we put 24 here, divide by 24, it's 1 minus 1 squared 0 times 0. So it's clearly empty after 24 hours. Okay. Use the product rule to determine how quickly the gas is leaking from the tank when the gas is 60% full. Well, we got a problem. We don't know our T value. What did they give us at the end? They told us how much the gas tank is full. What part of this formula is that? T measures time. They've given us how much volume is left in the tank. How much is a full tank? 75. 60% full. How do I figure that out? You multiply 65 times 0.6. Another way to look at it is you multiply it by 60%. But 60% is written like this. Well, yeah, I can multiply by 60 and divide by 100, or I could just simplify here and multiply by 6 and divide by 10, or, as I did, multiply it by 0.6. So when you multiply this by 0.6, you get 6 times 42, 45 liters. So 60% of a 75 liter tank is 45. Great, 45 liters. So now we know that when this tank is 60%, it's 45 liters. Still don't know T. We have to take this equation, clean it up a bit, because obviously I made a mess. And where do we put 45 liters? We don't put it here. 45 liters isn't a time. We put it here. Now we have to do reverse bed mass, SAMDEB, to figure it out. Is this got any subtraction and addition? Yes, but it's in a bracket. So brackets are at the end. Does it have any multiplication and division? Yeah, it's got a division here, but it's in the bracket, so we have to wait till the end. However, it does have one here. Okay, let's multiply by the reciprocal on both sides. Great. And why do we need T? Because you're going to need T to figure out the derivative, which is what they want to know. They want to know to determine how quickly the gas is leaking when the volume is 60%. Well, we need to know a T. Okay, so we're left with this on the left. And this has been canceled on the right. Great. We got rid of that part. Any exponents? Yep. How do I get rid of an exponent? Square root. Both sides. Square root demolishes the exponent. Great. Do I have any brackets? Yes, I do. Okay, let's solve what's in the brackets. So now you start your SAMDEB all over again. SAMDEB is just reverse order of operations. When you're trying to unravel equation to get at something in the equation, you kind of follow reverse order of operations. So we start it all over again. Any subtraction, division? Yes. Now you might be tempted to add T to the 24, but now we got T over here being added to this. And you can do that, or you can do that property I told you before. This is the same as this. 1 minus that is the same as minus that plus 1. Well, we need to get rid of anything being added to this thing before we get to the multiplication division. We're going to subtract 1. So on the left side we get, okay, anything multiplying it? Yeah, technically it's being divided by minus 24. So we're going to multiply it by minus 24 and get rid of the minus at the same time as the reciprocal, because that's being divided by it. Great. Put this whole thing in brackets, by the way. So these will cancel out here, which means the left side I must multiply by minus 24, wherever I can put it. Hang on. Good, I'm left with this. T is equal to this. All we have to do is take this, and we have to take the square root, and we have to subtract 1, and we have to multiply by 24, negative. And we get that. So T is indeed this time. And let's be nice to ourselves and just round it up to 5.41. T is this many hours, and we'll just keep it as a decimal for now. What is that, by the way? What is 5.41 hours? Well, it's 5 hours and 41% of 60 minutes. So you would take 0.41 and multiply it by 60 minutes. If you wanted to. Let's not do it just yet. It is 24.6 minutes. And now you can do that again with 60 seconds. You discover that it's 24 minutes and 36 seconds. So it's 5 hours, 24 minutes, 36 seconds. But let's keep it in decimal. So we found a time when the tank is 60% full, and now we need a slope of the tangent. So the important thing was finding the time that matches 45 liters, or 60% full. Now we can take this equation and we can use the product rule. Well, fortunately, all we have to do is do the chain rule. We do 2 times that, 150, and we lower that by 1. Great. But then we have to take the derivative. We have to multiply it by the derivative of the content. And you might get really confused at this point, because a lot of students can't see what that is. That is 1 minus 1/24 times t to the 1. It's a minus in front of it. What's the derivative of that? The 1 comes down, multiplies the minus 1, becomes a 0, so that just becomes 1. So 1 times minus 1, minus 1, 24ths. That's the derivative of that, minus 1 over 24. It's just the coefficient in front of the t. So we replace that with a multiplier of minus 1 over 24. Now you can simplify this. This times minus 1 over 24 is 150 over 24. 150 over minus 24 is 6.25. So now we have a multiplier of minus 6. I didn't even write it down. I think it was 6.25. 6.25 times, we can get rid of that. Boom, we got much nicer. What was our t? What was our t? We found it right there. So we take 1 and we're going to subtract this fraction, which is roughly 1/5. So we should be left with roughly 0.8. So 1 minus 5.41 divided by 24. And your calculator will remember order of operations unless you have a faulty calculator. So that means I now have this times this. Negative 6.25 negative. And I get this, which means it's going down, This is the slope. You might be overwhelmed by that, but it's really unravel, unravel, unravel. And then you got to use your units. We know it's liters per hour because they gave us t as hours and volume in liters. So it is losing at that particular time, which was 5.41 hours, I think. It is losing 4.8411, whatever, rounded up. It is losing it's going down negative 4.84 liters per hour at that particular time when it's lost 60% of its gas. So it's draining quite quickly. And as a parabola, it's going to drain very quickly once it's down there. And yeah, sorry, this is a downward facing parabola. Because to get it in parabola form, you'd factor out a negative out here, and you'd get it as t over 24 minus 1 squared. Much clearer like that it's a downward facing parabola. And of course at 24 it's empty. And this was only 5 hours in. It was important also to know it was 60% full of gas and not 60% empty of gas. Those are two different things. 60% empty of gas is 40% full of gas. Anyway, that's how you unravel these word puzzles. And as you can see, they're a pain. I love them, but, you know, if you're just trying to get to university, they're a pain. And I understand that. But that doesn't mean you should give up. Determine the slope of the tangent for this function, clearly a nasty function, at this. Explain how to find the equation of normal at that. So before we do that, I want you just to pretend you've got a weird function, right? Let's see. There we go. That's good enough. And understand that the tangent is the 90 degrees to the point you're looking at. So let's say I didn't quite get it. It's probably closer to that point. What about there? Well, the normal is a line that will form a 90-degree angle to your tangent line. And what is the slope of any perpendicular thing? It's the negative reciprocal. Remember that. So that means I have to find the slope to figure out the line of the normal tangent line, and then use the reverse slope. Actually, all I need is the slope, and then but then I have to figure out the point it's at to figure out this line. Essentially, you'll need this point, and you'll need this slope. All right, so my first step would be to figure out what point we're talking about, and if you want to do visually, x times x squared, we're dealing with a cubic. So we're dealing with something that's coming down. It's positive in front. It's coming down from quadrant 2. It's doing a wiggle and going back up to quadrant 4. So to the powers of 4 are always like w's. If they're negative in front, they're always like upside down w's. And they're not always a w, but they can be a w. And as you can see, it can possibly cross the axis at x-axis at 4 times, or not at all. So remember your graphs, because they're going to come in handy in through Chapter 3. So my first step would be to figure out the point we're talking about. And look what I did to all the beautiful equation up top. Shame on me. Let's see if I still have it. I do. Great. I'm going to do this one and then stop and see how long these things take. And I'm going to assign function f here, function g here, function h. But first I'm going to find out what point we're dealing with. Minus 2 here, minus 4. Minus 2 here, times minus 1. Minus 1 cubed is still minus 1. Minus 2 here is 4 plus, minus 4 plus 1. So those cancel out. We're just talking about 1 squared. So we're talking about minus 4 times minus 1 times 1 plus 4. So we're talking about y4. So hang on, let me just, buggers. So I figured out that the y value here is positive 4. Important to hang on to that. So now we got to find the equation of the tangent to figure out the slope when x is minus 2. And that means I can assign it as f, g, and h. And I might want to just go a little higher, g and h. And over here, I'm going to put f, g, and h. And keep them nearby. And then I'm going to figure out the derivatives. So what's f of this? It's 2. That's easy. This one I have to follow the chain rule. I cheated, used the 2. And then I have to multiply it by the derivatives of the content. Well, that's easy. That's just 1, so I don't have to do it at all. Then this one, I have to use the chain rule. And then I have to multiply it by the derivatives of the content. Derivative of that is 2x plus 2. So now I have the derivative of h and the derivative of g and the derivative of f. And then I just go back to my product rule, which is it's going to be f times g times h prime plus f times h plus g prime plus h times g times f prime. you're going to need a lot of room for this one. So as I do it, I'm going to slide this thing up. So it's F times G times H prime. H prime's the longest one. And yeah, I can simplify it. So I had 2x plus 2 here, and I had 2 here, so it's 4x plus 4. So instead of having the 2 in front and this at the back, I'm going to put 4x plus 4 in front of it, and just save me one extra step. By the way, I got to keep that over here as a copy, because I might need it again. I don't know. So again, my point is that I'm going to just multiply it by this instead of the 2 and the 2x plus 1. Great. That makes it a little bit more room. And now I've got to add, and I might have to go down below. The f, and look at that. I already moved my f. Stupid. So I believe my f was this one. And I'll keep it up there. Good reason not to move your things too much. Woo! Running out of room. So I've got my f. You can see how confusing I can get. Plus my f times my g. No, times my h, rather. Times my g prime. Yeah, I should have hung on to my h again. And finally I got my h, which I'll grab from here. Times my g, which I'll grab from here. Times my f prime, which is easy. It's just 2. Yikes. Whew. Now, fortunately, they gave us a softball number. And you're going to want to remember to have a plus, you know, in between there and over here. The softball number they gave us was minus 2x. Minus 2 plus 1, minus 1. Minus 1 cubed, minus 1. Minus 2 times 2, minus 4. Minus 4 times minus 1, plus 4. Times, so far so good, 4 times minus 2 minus 8 plus 4, minus 4. 4 times minus 4. Minus 2 into this one is 4. Minus 4, 0 times 1. So what's plus 4 times minus 4 times 1? Minus 16. So this whole thing, if I did it right, is minus 16. Now obviously if you keep more orderly notes, it's going to be better. So now I plug minus 2 in here. I get minus 4. Minus 2 in here. I get 4 minus 4 plus 1 squared, which is just 1. So times 1 times minus 4, minus 2 in here, plus 1 is minus 1, squared is plus 1, times 3 plus 3. 3 times minus 4, minus 12. So instead of plus minus 12, I just put minus 12. Then I down here, minus 2 squared, 4, times minus 2, yeah, this is going to just be 1. Minus 2 times here, minus 1 cubed, minus 1, times 2, plus 2 times minus 2. Minus 2. So my final answer is that the tangent is minus 30. This tangent is going to be the slope of the tangent at this point. But the reverse is going to be the normal slope. What's the reverse of minus 30? It's plus 1 over 30. So right now, I know that I have the normal equation will be this. Oh, not m, x, because that's the m. The m of the normal is the inverse and opposite sign of that. I just got to figure out b. Well, I have my two values of x. That's why I did it. So I got 4 for y and minus 2 for x. So minus 2 times 1 divided by 30 becomes minus 1 over 15. And keep your thing over, minus 1 over 15. So b is going to be equal to 4 plus 1 over 15. And if you want to put that into a full fraction thing, it's 61 over 15. Which means I can now write my equation of my normal line as y is equal to 1 over 30x plus 61 over 15. You can even multiply that all by 30, and you get 30y is equal to x plus 122. And that's probably what the book shows, because they don't like to have the fractions as slopes. Personally, this thing is the same as the thing we just had. So this is just as accurate right there, but it's uglier. So if you multiply right through this equation by 30, you get rid of that, and you're left with a multiplier of 2 here and a multiplier of 30 here and just x here. And it's why in the book you'll see them write their line equations like this. Which is the same as that. I'm going to stop here. I'm going to continue in a little bit. You can see how slow and long it takes, but the more you do it, the easier it is on a test.